So today's session is all about data workloads with Snowflake and DBT. So I am Ronaldo from the data services team, and to introduce about myself, I have recently joined in LatentView into the data services practice, and my previous experience was with Cognizant, and earlier to that it was with CGI, and I've been in IT for 14 years now. So that's my background. And today I'm going to take the session about data workloads with Snowflake and DBT, with Snowflake being a recent game changer in the big data industry. So let's learn about Snowflake and what is DBT and how both together work on data workloads. So the session agenda is first, there will be an introduction to Snowflake, and then the introduction to DBT, which will be very brief. The Snowflake would be the most part of the session, and there will be a brief introduction to DBT, and there will be a demo on Snowflake and DBT on basic features. So the demo would be very basic with regards to how you start using Snowflake and how do you start using DBT. And then at the end, there will be a questionnaire where you can clarify your doubts. So that's about it. So let's jump into the session now. So as the title says here, the real world struggle in data engineering. So I guess the participants who are intended to attend this session are mostly data engineering team, data engineers who would be interested to know what Snowflake is offering and what kind of difference it has made to the data engineering. So let me just come up with the first actual problem statement, that is the real world struggle what we face in data engineering. So let me go through it. So first, we all would have faced the scenario of loading data from multiple sources, different formats, and there will be an immediate need of loading data. So we'll have to find a way how to load data into our particular environment, lake or database, whatever. So that's one of the challenges we have been facing in data engineering, and we keep on finding solutions for that, right? There are different tools and different providers which help us in doing that, and so that is something which is evolving. And the next is integrating data. Like I said, there are multiple, you might have to integrate data from multiple systems, multiple source systems, and you might have to build complex data pipelines. And there should be resources with specialized skills and resources, like when you have multiple sources, like one in SAP, Salesforce, Oracle, SQL, and you might have to search for experts in each area to integrate all your source data and build pipelines and bring the data into your destination, and which could be useful for their reporting. So that is one of the things. And then after you bring it to your target environment, you will have to analyze the data in order to make decisions. So this analysis would have to run on a good computing way, so that you can easily see a vision on what the data is all about. So you'll have to optimize the data and all the stuff. And the next is collaboration. Like once you have analyzed and you have made the report ready data, like the business or the stakeholders has to see the data, collaborate on the data, like the IT team and the business team has to collaborate and come up with some decisions on the data. So this is the current struggle we face actually, and we have solutions. I won't say there is no solution. We have solutions for everything, but everything together, Snowflake gives you one-stop solution where it helps you in loading, integrating, analysis, and also collaboration. So that is the game-changing feature which Snowflake has given, and it's completely a cloud data warehouse as a service. So we have this platform as a service, infrastructure service in the cloud. So this is a data warehouse as a service which provides you the capability of loading, integrating, analyzing, and also collaborating data. So that is how Snowflake helps you. And going to the next thing. So as I said, Snowflake serves as a one-stop solution. So this slides gives you an overall high-level view on how the data comes into Snowflake and how so this is the structure of any data pipeline, right? Any tool, be it AWS or Azure or Google Cloud or your legacy systems which build pipelines to bring data from source systems to the target system, your data warehouse, and then your analytics, or your reporting applications, your predictive algorithms, whatever has to run on that data warehouse. So we'll have to provide a complex architecture where we'll have to extract the data from the source, store it in some place, then do some transformations using different tools which would require different expertise, and then bring it back to your target database, and then give it to the analytics team for the exploration using BI reporting and stuff like that. So here Snowflake gives you a complete one hub store, which would help you to connect to different data, diverse environment, which would have a data warehouse, which would have the cloud capability where you can scale up and down, and you can take care of your workloads, computes, concurrency, everything. So 100% cloud data warehouse, which also helps in connecting to the reporting environments as well. So this is the game-changing solution Snowflake has given us. So this is the high-level view on Snowflake. And next, going on to that. So what makes Snowflake unique? So let's go through that one by one. So it's a single platform, as you said in the previous slide. So it's a single platform which helps you to integrate with data and also give the data for analysis. So that is one unique feature which other data warehouse which is in cloud doesn't provide as of now, right? Because we have to have data pipelines before that to do all the transformations, and then store it for the data in the data warehouse for reporting. But here you can do your transformations inside Snowflake itself by even connecting to the stage environment to bring in the data, which you'll see later. And this is a single platform, as I said. And separation of compute and storage, which is something very unique, which Snowflake is providing. So here in this cloud, the storage and the compute, the servers and the compute uh, capability, which is given by Snowflake, is separated so that you can use it according. So there might be some customers who require more compute power and less storage, and there might be some customers who require less compute power and more storage. So in that case, it separates you the compute and storage, and it also auto scales. If you want more compute, it scales up, and if you want less, it scales down, and it is automatic. So that is one capability which is unique in Snowflake. And next, it is a secure and governed access to all. So the security is taken care of in all the cloud providers. So Snowflake security and governance is managed by the Snowflake itself, where you have the role-based access and everything defined within Snowflake itself. Uh, and next, it gives you unlimited performance and scalability. So what do we mean by unlimited performance? So in other data warehouses, you'll have to optimize your queries, what you write, in order to in order for it to run efficiently, uh, indexing and other stuff. So many stuff we have to do, and also you'll have to increase your processing units in order to make the performance feasible for any workloads. But here it gives you unlimited performance and scalability by means the optimization and the performance tuning is automatically done within the Snowflake itself. You don't have to do anything on the performance tuning side. And also the scalability, as I said, it auto scales up and down on the performance side. So that is one other unique feature which you can see. And it's an easy to use platform as a service, as I said. So it's a web interface. We all can first start with using a trial account, and then according to your requirement, there are different pricing structures where you can take the different versions of the Snowflake and go accordingly. So that is one thing. And next, you don't have to manage anything. I mean, the infrastructure, your query optimization, as I said. So everything is done by the Snowflake itself. So that is the main unique features what you can see in Snowflake. So now, as he said, right, the easy to use the Snowflake offers you different pricing structure, which is not essential now. So let's go to the next Snowflake architecture. So as I said, the service compute storage. You see, this is the architecture of the Snowflake. You have a centralized storage of your data warehouse, which has instant automatic scalability and elasticity. And this capability depends on, as I said, right, you have different pricing structures where you have standard, enterprise, business critical, and virtual private Snowflake, which is available. You can choose what you want according to your requirement, and depends on that, it will increase your scalability and elasticity. I guess the elasticity is scaling, elasticity is available only in business like higher two version, that is business critical and virtual private Snowflake. And in this architecture, so as I said, it's a centralized storage, and then the compute, like the development, ad hoc analytics, loading, everything can happen within the Snowflake itself. And the services optimization, it is automatically done. Management is automatically done. Transactions, security, metadata, everything is automatically captured. So this is what the Snowflake architecture is all about. And we move on to the next slide. Now, this gives you the data workflow on a high level view again. So, this slide, like now, the very very interesting fact is Snowflake can be hosted in Google Cloud, AWS, and Azure, which is the leading cloud provider as of now. So, it can run on all the three environments: Google Cloud, AWS, and Azure. So, so the middle portion is the Snowflake data warehouse, as I said, which serves as for data engineering. It serves as a data lake where you can connect to any of these Google Cloud, AWS, Azure to connect to files, and it acts as a data warehouse. The data inside the data warehouse can be used for the data science, and the data can be given for applications, and the data can also be exchanged with the business users as a collaboration, as I said. So this is a part of the unique structure which gives it everything at one place. And as I said, on the left, it is data sources. You can connect to any data sources, OLTP, enterprise applications, third party, web, IoT. And you also have Snowflake on the right side, which can connect to the consumers like reporting, analysis, real-time analytics, anything. So this is about the data workflow. And now this talks about the essential feature which is given, like you don't have to do anything with the infrastructure knowledge or tuning. So the infrastructure management is automatic, and virtual hardware and software managed by Snowflake. You don't have to do anything. And the data storage management, and it is like adaptive data distribution. It distributes itself in the most optimistic way, and it automatically compresses, and it automatically optimizes the data. So you don't have to worry about how do you define your data in order how it could be distributed, like in other data warehouse, maybe in Azure, if you take, there are different options you have to mention when you create a table, like whether it is distributed in round robin or hash, or different type of with respect to the table, like whether you're using fact or dimension or whatever transaction tables. So in this case, you don't have to define anything. You just create a table, and Snowflake takes care of everything there, like the data distribution, automatic compression, everything. And the metadata management, so automatic statistics, collection, scaling, redundancy, everything is managed inside. And you have Snowflake automatically taking care of the metadata. And as I already said, right, the query optimization, you don't have to do any optimization with respect to the query on concurrency, parallelization, or performance tuning. Everything is taken care by Snowflake itself. So it seems very interesting, right? So let's go on to the next stuff. And the next important feature is there. See, other data warehouses, like other than Snowflake, you always depend on structured data, right? So here Snowflake gives you a very cool feature where you can handle semi-structured and also the structured data. So your Storage can connect to different stages to read semi-structured data like JSON, Avro, XML, ORC, Parquet, kind of, and it can also read structured data like CSV, TSV, etc. So this can be read and kept in a stage, and then you can do your transformations and then move to a target. So as I said here, uh, you can read the data, then have a stage environment with these data read into Snowflake, and then you can have a transform the data, and then your that can be given to the next stages to be queried, like what data you want. So optimize SQL querying, full benefit of database optimization, as I said. So everything is taken care. So this is another cool feature. Like it has everything. Like it can handle structured and semi-structured data. And now let me just talk about data pipeline in Snowflake. So as I said, right, Snowflake is going to, so this is a bit an explanatory view on the things what we saw earlier. So we have different sources where IoT, mobile, enterprise apps, or OLTP databases, whatever. So we have different connectors in Snowflake. Like we have a Kafka connector, which can help in getting the real-time streaming data, and we have this external stage, which can connect to S3, AWS S3, Azure Blobs, Google Storage, and all, and this can also be auto ingested, like using a snow pipe, which is a feature available in Snow. So once you connect the stage, which we can see in our demo, like how do we connect to a stage, so that I can show you in the demo. So once you connect a stage, we can schedule an auto ingest, like a micro batch snow pipe or a bulk load copy into a staging environment within Snowflake. And after that, you can write your transformation queries, which can move the staging data into the target tables. And there is some cool feature which is called table streams and tasks, which can be used in scheduling the transformations on a regular basis. It's kind of a data pipeline, as I said. On a periodic way, can move into the target tables. So this is about the data pipeline in Snowflake. Okay. So next, on why Snowflake is getting famous with enterprises. So this is some points we'll have to check. And so as I already explained, this is a modern cloud data warehouse which serves as a data lake, data mart, open data store, which can collaborate with the business users and also to the reporting applications. And this supports various programming languages like Python, Java, .NET, Node.js, C, SQL, Alchemy. So it provides you all the big data capabilities, all the languages which we can write in order to do the transformations within Snowflake. And it can be served in many platforms such as machine learning, data science, business intelligence, data integration, security, and governance. So it is you. So as I said, it's a holistic product which provides you everything in one shot, and separates the storage and computation, which we discussed earlier. Like it gives you a different layer for computation layer for scalability and cost effectiveness. So that is something which we can say. So I kept talking about this separation of storage and compute. So let me little in little detail. Let me give a view about it. So let's take a data warehouse wherein a real time data warehouse where you have the goods and goods stored at a warehouse, and there will be workers who will be working inside the warehouse who will be moving the goods inside and out. So in the traditional data warehousing system, so within the computer languages, I mean, now so you have data which is called the goods in the real-time environment, and you'll have servers which are the workers. So the load of the warehouse performance depends on the data and the service you have. So Snowflake actually says for the storage and the compute, it will stand for the data and the service in the traditional data warehousing terms. So your data will be the storage and the service will be the compute. And this particular thing is separated so that depending on your data, your storage will increase, and depending on your workload, the compute will increase. So if you take the real-time data warehouse, it depends on your goods, your the size of the warehouse has increase, and depends on the worker, the goods the worker has to increase. The same way, the storage and compute, it's not complicated. Uh, they are separated so that they can scale up and scale down efficiently, so that your cost effectiveness comes into picture there. So this is about Snowflake. So I think we have we have had a good introduction about Snowflake. Now let me jump into DBT. DBT is data build tool, and it's a development environment that speaks the easy language of all the data analysts, which is SQL, right? So with DBT, Snowflake already gives you the capability of the data pipelines, as I said, right? The transformations can happen through stream and tasks, and all those scheduling can happen. The orchestration can happen within that. But going with DBT, like the Snowflake, when it goes with DBT, it seems more powerful because of the reason that it has this version control, alerting, logging, and also the documentation part. So this particular DBT, when it goes along with Snowflake, you can have the raw data, which can be transformed into the target tables, and your testing can be automated within DBT, and you can have your deployments automated within DBT to be deployed into the Snowflake, and you can also have the documentation set up. And with all these capabilities, DBT goes very well with Snowflake. So that is why the session was focusing on talking about the data workloads of Snowflake with DBT. So Snowflake can handle that, like as I said, like the transformation, scheduling, orchestration, anything. But when it goes with DBT, you have more features which comes into picture in more simple terms with SQL, wherein you can have version control, alerting, logging, and everything. So this is the DBT architecture. So you load your raw data, and then when DBT comes into picture, you can have a snapshot of your raw data. You can have a transformed data. Then you can have your test scheduled. You can have your deployment document of all the data what is available, and version control of your deployments, logging, alerting, and everything, and then the transform data. So this is about DBT, the introduction about DBT. And why DBT is Snowflake? Like I already said, it's a game changing approach to managing ELT workloads, orchestration, and managing processing pipeline. Sorry. And DBT provides a unique level of DataOps functionality that enables Snowflake to do what it does well. As I said, it already does it, but DBT gives you more features in terms of documentation, test automation, versioning, and all those stuff. And sorry, guys, for my throat. And DBT brings Snowflake engineering world as SQL savvy ETL developer. Like I said, you can write SQL commands inside DBT, and inside DBT, the SQL queries are treated as models which can be deployed and used as a transformation queries. So the model can be versioned, and as I said, right, it takes care of the versioning. The models can be versioned, and the schema and data can be tested, uh, which can serve as a unit test, and automation testing can be done. So mostly DBT helps in the transformation, versioning, and also in the deployment of the Snowflake. So the models are linked by reference to form a DAG, which is direct acyclic graph, which in terms represent the order of query execution, the way the query had to be executed, as well as to capture the data lineage in the generated models. So this is about DBT. So as I said, DBT, it's a short, brief introduction to DBT. And now let's jump into the demo where I can show you about Snowflake. basic Snowflake environment and how do you work with Snowflake, how to create a stage environment, and then a brief introduction to DBT and a small deployment with DBT as well. So let me jump into DBT demo now. So any clarifications? Maybe if you are fine, we can take it after the demo. If you want, I can answer your questions if you have something now. I'll give you 2 minutes before I start. Next.
Ronaldo, can you hear me? This is Karthik here.
Yes, Karthik, I can hear you.
Yeah, hi. Hey, thanks for this. They're very useful. Quick question in terms of the database itself, right? So is it more like a column-oriented data store, or it is still a row major, or you have options to do both?
Yeah, the database is a column-oriented data store. You have options to integrate data from different structures, but at last the storage would be like a table column kind of database only.
Correct. So as far as the structure is concerned and the way you issue SQL queries, it will be the same. But under the cars, it is a column-oriented data, like a Redshift.
Yes, exactly.
Okay, so just to compare a Redshift to a Snowflake, the big advantage, of course, there are a lot of advantages that you spoke about, but to think about it in a very simplistic manner, Redshift is available only on AWS, whereas Snowflake, you can have it across platforms. That is one major advantage, right?
Yeah, exactly. And also about the separation of compute and storage, I don't think AWS has that, right? Redshift.
Okay, again, I don't know about too much
even
about
I'm not
Redshift,
very
but
clear.
I have heard.
Yeah.
Okay.
You're going, Karthik.
Okay, but yeah. Got it. So that is definitely an advantage. Possibly it is there in Redshift also, but the storage compute is also very interesting, right?
Yes,
typically,
yeah.
Because the storage, you might store more data, or in many cases, the data might be small, but then you might issue a lot of concurrent queries and things like that, in which case the compute needs to be scaled up.
Yeah,
right?
yeah.
That part of it is definitely interesting. I had just one more question, which I actually forgot now. Sorry, you can go ahead with the demo. I will probably remember the question.
No worries. No problem.
Thanks.
So the demo is.
No, I have one more query. I'm sorry.
No problem. Yeah. Please go on.
The thing is, in one of the slides, right, you showed there's an integration between semi normalized data and then normalized data, right? I mean, the structured data and unstructured data.
Yeah.
Right? Yeah. So how are you combining? Basically, right? You have a layer that will combine both unstructured and structured. So what that layer does basically. So if I need a column from structured data and if I need a column from unstructured data, so how the combining will happen here?
So basically what you do is, see, maybe one of my demo might give a clear picture, but to be in a brief state. So bringing in the semi-structured data. So you read, see, first of all, you have to define a stage. Where do you read that semi-structured data? Like be it JSON, Avro, XML, whatever. You will have to define a stage like AWS S3 bucket or Azure Blob or GCS, right? So you will provide the credentials and connect that stage. So that stage environment will reside within Snowflake. So once you have defined a stage, you can read all the data from that AWS S3 or Google Storage or from Azure Blob. So while reading, you can read using different functions like JSON or XML and then store it into a stage table, which you create within your Snowflake inside your database or schema. And then that will serve as your stage table. So same way, you can also have a stage where you can bring in your CSV data or TSV data, whatever, into your stage table. So now you have both the stage table, which can be connected to taken into your target table. Does it answer?
Yeah, because so for example, right, if you input in JSON data, right, so it would have in a tree structure. So converting a tree structure into a table, right, there'll be a lot of challenges, right? So that's where That's why we go for a NoSQL database. So converting a tree structure to a structured database, do you think it will be a challenge? Like
that place, like there we have to functionally first understand what data we are reading, and we will have to uh, uh, probably map what we are going to read and how we are going to store in the stage. That preliminary analysis and stuffs we have to do, and then bring it, and then you can do that.
okay, so basically, right, at the end, right, we need to keep in our mind that we are storing the data in structured format, but we bring in the JSON.
Yes.
We can't bring a something which is has lot of tree structure to it, and then if you're trying to fit that into a table structure, it will be a challenge. Correct?
Yes. Yeah. It depends on
Thanks.
customer or the different requirements. Yeah.
Okay. So is there any programming kind of processing we can do in this layer? Like, so we bring in the entire structure and then we'll feed in only the features which we needed in the stage table. Is the layer like I can do some programming on top of that unstructured data?
Yeah. Programming on top of the unstructured data. Yeah, I think there are variables. As I said, right, there are different languages which can be used within your Snowflake, right, Python and others. So once you have your stage, you can use your programming language to do different things before you bring it to the stage table. That you can do definitely.
Okay. This
So
seems an
that is,
interesting stuff actually.
yeah,
So
that's a
combining.
very interesting capability. Yes. So as I said, it takes you can have all these programming language like Python, Java, .NET, right? Everything can be used. So once you have your stage, you can read the data from your different semi-structured data with the language of your comfort, and then do whatever you want, and then store it to the structured layer.
Okay. Thanks.
Yeah, no problem. And a quick thing is like this demo is not going to have any complex kind of thing. It's just going to be a very basic thing, just to show an idea on Snowflake and DBT. So it's just about creating database table and stuff like that. So and I just want to set the expectations for that. Okay, so let's go ahead. So once I think when you all have want to try Snowflake, you will have to just so when you go to the Snowflake login page, you will have this start for free. So you can register yourself and you can start. And I think you will have a 30 days trial. Once you have your email registered and you start the trial, I think you can play around with what that Snowflake actually. So once you have registered, you will be taken to the login page, and once you log in, so this is how it looks. They will send you a login link verification, which will look like this, which would probably be the data center where your Snowflake is hosted, and you will have a separate URL for you, your trial account. So you'll have to log in. So I've logged in now. So when you log in, so this is where on the top your username, and by default you will be as a sysadmin, and there are 5 roles: account admin, which has the most highest privilege, and default is sysadmin, as I said. Then public, security, and user admin. Each of it has a different privilege to be handled. So the default is sysadmin. So let's go on with the sysadmin now. So once you have the sysadmin logged in, so you have this on the top. You see databases, shares, data marketplace, warehouses, worksheets, history, and this all. So we are going to see about database, warehouse, worksheets for now. So when you click on this databases, you have the different databases which are available by default. So by default, you'll have all these three, I guess. Snowflake sample data, demo DB, and util DB. These two are something which I tried, so you can ignore that. This is what you would see by default when you log in. And so when you browse through a DB, I guess if you can just go inside a DB, and this is how it looks like. So when you go inside a DB, so you see this breadcrumb here. So we are inside database and inside the DB Snowflake sample data. And you have tables which are listed here, different tables which is within this database, and then different views within that database, schemas, stages. Stages is something we'll come into, we'll see in the coming time, and file formats, sequences, and pipes. Okay. So we'll not looking into, with the interest of time, we'll not be looking into everything right now. So we'll just look into the basic features, and then you have you can create your trial account and explore around it probably. So when you want to click on a table, so if you click on a table, you have the breadcrumbs show you that you are on the table now, and the one within the bracket is the schema within which the table lies, and this will give you the value of the column names and its properties here. So this is about the database navigation. Now let me go to warehouse. So warehouse is something by default you have this compute warehouse, compute underscore WH, which should be available, and you can create your different data warehouses. So what is the need of warehouse? Warehouse is for processing power, which is required to execute a SQL command. So you can have different warehouses, and as I said, it can be auto suspended and auto resumed. So you need not take worry about switching on a warehouse and shutting down a warehouse. So you can have this setting enabled on all the warehouse so that it will be active only when some query is invoked. Normally it is in the suspended mode. So whenever some query is fired using that warehouse, that will automatically it will not take much time. Immediately it will switch on and execute actually. So that is one thing. So this is about warehouse, and let's try to create one warehouse now, just to show you how it feels. So this is how easy you can create your warehouse, and the size of the warehouse you can just define like with respect to your requirement. So X small, medium, large, X large, 2X large, the different types of sizes you have. So in Snowflake documentation, where we can see like what each sizes means and what's the pricing and credit and stuff like that. So if we take small, so it gives you like the maximum of clusters and minimum clusters which it use, and the scaling policy, as I said, it's as per the pricing policy standard, and auto suspend in 10 minutes, which you can change accordingly you want, according to your need, whatever you want. And let's leave this as default, and when I say finish, and that's how fast it creates actually. So we have a warehouse ready now for operation. So now let's go to database, and we'll try to create one database now. So I have some demo which I'm So I've taken an example of USDA nutrient database, so which from some of the learning materials. So I'm using that for the demo here. So let me just show you. Create a database now named as USDA nutrient standard ref. So you can also see the SQL which is used behind creating this data warehouse. Actually, create a simple SQL command. So you just say finish. and your warehouse, your database is created. So let me click on my database, which is now empty, which doesn't have any table. So let's try to create one table. So I have some sample files here. Let me show you that. Which we can, so I'll show one or two files to be ingested and checked upon. So now let me create a table which would, so food group. This table, I'll try to create this table using the interface itself. So it's create, and you can, the schema, you can choose the schema. So normally it's in public, so you can leave it in public. And the columns, with how you want the column. So in the interest of time, like I'm not getting into much details, but generally what happens is you will have to understand this file. See, and accordingly, you'll have to create the structure of the table. But let me just show you that. So the description of this file and all I have in a different thing. So in your requirements, you'll definitely have whatever you're going to ingest, you will have the details about it. So with respect to that, we'll have to create it. So let me just go into creating this table now. Code. And let me change the type to okay. So the description of the data type and the length of the data were provided by the standard functional requirement of this particular files actually. So it depends on what requirements you have with your customer. So here it is, this column will have 4 length and this will have 60. So let me just create this table. And now the table is created. So now let's try to load data into this table. Okay, so go to the table. So here, if you click on the table, you have this load table, and loading of table will require 4 different configurations which you'll have to do. So first you have to select the warehouse. So let me go with the warehouse which we created now, sample warehouse, and next you have to select your sample file. You can do it from the external stage or from your computer. Right now I'm going with our computer. So this is the file actually, group. Next is the file format. We don't have a file format right now. So let's go ahead and create a file format. So So you can create different file formats with respect to what you have with your source. Actually, you will have different type of files, right? CSV, TSV. Within that, you have different delimiters. So for each delimiters or columns, each type, you can create one file format and you can reuse that across the different tables you're ingesting. So right now, this file, when I opened it, I think you might have noticed that this file had special characters of tildes and caret symbols, which you see here. So I'm creating this file format using that actually. And format type is CSV because it's a text format. And so now the column separator, it is not a comma, vertical bar, tab, or none. So it's a different separator we have, which is caret symbol. So I'll choose other, and I'll use tilde as a column separator, which is in your keyboard. You can see in number 6. You can use shift 6 and you will find this actually. So rest of the things, I'll just leave it as it is, and I'll just go ahead to create this. So the file format is created. Now we go to the next step, and load option is stop. So there are different options for load. So do not load any data, stop loading and roll back if there is an error. So I'll go with this value, stop loading and roll back. Okay, so you have an error. I expected this error because when you see the file format, you have this tilde here, wherein when you described your column, the length was only 4, but this is taking another 2 spaces of each column. So we cannot load it here. So this is where the stage comes into picture. So let me go ahead and create another table now. It should be FT group ingest. And it's the same columns. It's kind of an intermediate table, which is used to remove that characters. So I'm just doing this because in order to show the transformation we can do within the SQL actually. So let me change the data type. 6. So now this has been created, and click on this table and load data. Same, let's select the warehouse we created, choose the file which we wanted to load. So file format is already created, so I think we'll go with the same file format and go to the next stage, same setting, and I'll load now. So there has been, the data has been loaded. That is 25 rows. How to check this? You go to worksheets. So worksheets is a place where you can navigate and check your data actually, what you're loading. So So when you okay, on this left side of the worksheets page, you can see your database is listed here. So we'll have to select our database which we have created. So this is the refresh button. So you can navigate within that. So public is our schema, and these are the 2 tables which we have created now within that database actually. So when you use a select query, actually, you have to use the full qualified name in order to query that actually. So in order to get the fully qualified name, so you just click on these 3 dots on your table, say, place name in SQL. If you click on this, that comes here. So you can select this and run the data. So you can see the data loaded with the tildes before and after. So the caret has been the column delimiter, and we have loaded it into different columns now. Now, so there are different functions. So as I said, right, you can use different capabilities to do the transformations and stuff like that. So now we have used a simple SQL here. So you can replace the tilde with an empty space here, or an empty string, and then load it to the actual table. So I'm running this select query here, and if you run the insert, it's going to insert into the actual table. So 25 rows has been loaded here. Now, if we select from the actual table, you have the data without tilts. Okay. So now let's go to our databases. So this is about just how do we take data from a file, and as I said, I'm just taking only simple examples in the interest of time, and it's just loaded one file, and we have just made a simple transformation and loaded into the actual table. So that's what we have done. Now let me take you through another different thing. The file format we have seen, I think, which is stage. Okay. So now there is no stage. So let me create a stage here. So this is where you'll, it is interesting actually. So I have a AWS S3 bucket, which has a few files actually. So I'll just show you that how to link this Snowflake to AWS S3 bucket, and then list down the files, and then after that how to read files from that. So now I'm just going to create a stage here. So you will be given an option to choose which provider you are going to use. So let me choose S3 here, and I go to next. So let me give a name to my stage, my S3. And I have my credentials, which we'll have to get it with respect to our projects requirement. You'll have to mention the key and secret key in order to connect to the bucket. When I say finish, S3 bucket has been created. Okay, so my S3 bucket is the stage which I have created. So this directly is interfacing with the Amazon S3 bucket. Now let me go to the worksheet. So I can list down what is available within this bucket now. So list is the command what we use to see what is available within that. So now you are listing the data which is available in Amazon S3 bucket. See, if you see here, these are the number of files and the size of the file which is available inside the S3 bucket which I have connected now. So you can connect n number of stages like this, and with that you can read data from that buckets and then go ahead with your next. So let me show a simple demo now. So now it's at the root level. So if I just you can see the next stage is load, right? So if I say load, it will just give me the data within that load folder alone. So this is an interesting feature which we can connect to so likewise you can do it for Azure and also for this one, Google Storage. So now let me take another simple demo in order to read the data from S3 bucket. So now let me create a new table. You can create number of worksheets you want. So here you can choose which warehouse do you want and which database and everything. You can choose it here. Now let me create this table. So the table has been successfully created. And I'll also create a file format for this, which is a text, which will not be the same like earlier one. So now I'm doing it with query. Earlier we did it with the interface itself. Now we're doing it with the query. So you can see the delimiters mentioned here, right? So this file format is also created. So this is the command which you'll use to read from the S3 bucket and then store it, like read from the S3 bucket and insert it into our actual table here. So let me use this worksheet itself. So copy into wait ingest from my S3 bucket load, and the file name is wait.txt. And this is one of the syntax for that. So file format is USDA file format, which I just created. This one. So let me just run this query. So this is going to read from my S3 bucket and write into my there was a mistake here. Okay. Now, see, this is the number of rows loaded, and this is, and if you are trying to load it again, it will not load because it will say the file was already loaded before. So in order to load it again, probably if you want to duplicate, force is equal to true is something you have to give, I guess. And if you run it, I think you probably have to load it again. Yeah, see, it got loaded. Now it should have been duplicated, but let's not worry about it. So this is a basic demo about creating a stage. Like we used Amazon S3 and then loaded, read the data from our S3 bucket and loaded into our this one actual table, rating this. So, and we can also do a slight transformation into the data which is loaded. So let me just quickly run through that as well before I jump into DBT. I think we are already late. Create wait variable. Okay, now this is going to sheet. So this will, what it will do is create a new table called wait. Okay, and it will insert into wait by doing a simple transformations like replace and from the wait ingest table what we have now. So I'll just run this. Yeah, so as I said, right, it's duplicated now. We loaded twice by using force is equal to 2, and now this is the number of data loaded. So this is something I wanted to show in Snowflake. So it's very basic demo, like how we created a database table and then file format and then stage, and how we navigate through each stuff. So we talked about database, warehouse, and worksheets. Now let me quickly jump into DBT and what it serves with Snowflake. Okay, so DBT, as I said, it's a command line tool basically. So so installing DBT is something you can refer to the docs.getdbt. Like DBT, DBT's official website, where you can go to DBT CLI and installation, and just open your command line tool and okay, so it's you have to just follow this article here in order to install JIT and install DBT. Okay, with respect to your, so let me not go into that. Actually, you have to use pip. In order to use pip, you'll have to you should have Python and another thing already installed in your system. So which is already I've done it. So you'll have to run these two commands actually: pip install DBT and pip install upgrade DBT. Something which will install DBT in your system, and it will upgrade the DBT to the existing current version actually. So that I have already done. So once that is done, we'll have to, I'll just, I'm using GitLab as a repository actually in order to have this DBT initiated. So let me just take you through that. Give me a minute. So if I try to install it again, it would say it's already installed actually, or I don't have access to install. So this is how it will install actually. So once you have this, next thing what you'll have to do is you have to clone your repository, GitLab, or whatever you can use. See, I'm using GitLab here and repository to do a demo on this. You can use GitHub or Azure DevOps, Git, whatever is your. So you'll have to just clone the repository path from your repository which you are using from here. So I've just copied it. And now what you'll have to do is, okay, let me move to documents. This is the folder I use actually to create the repository. Now I'm just going to clone the repository here. So the cloning happened. Actually, I already would have cloned. So this is the repository I have cloned here actually. Now this is the one I earlier did actually. So within this now, I'll have to initiate the DBT in order to create models. So this is the command to do that. DBT. I think it's already existing. So, yeah, it already created it. So this is the structure which would actually create the initiation of DBT. So once this is done, so now let me show you how it looks in the Visual Studio Code actually. So when I open the folder, so I've opened the folder demo DBT in my actual documents. which I created earlier. So let's go with the same. So I open the folder, and this is how it looks here actually. So now this analysis, data, macros are all the folder structures within the demo DBT folder, which is created when I initiated the DBT product. And our important focus, macros is something which is very useful when you create functions which can be reused across. So let's not dive deeper into it now. So let's concentrate on the model alone. So my first model, second model is something you can create number of models here where you can write different SQL codes, as I said, which would be used for all within our Snowflake. So let me show you on how this can be pushed into Snowflake now. Okay. So when you always create, this is your profile in your project. So this is the project we created when I said init command using DBT, and this profile will be here. So I have kept my name of the project as demo DBT, and in this profile, when you name your project as demo DBT, you should always make sure that you also have your model name also in the same as you have above. So these two names should be same. That is an important point here. And next is the profile, which is used to connect to your Snowflake actually. So in this case, it's Snowflake. It can be Redshift or anything else. Right now, we are going to go with Snowflake. So when I did this init command, actually, you will have one of the profiles created within your user folder, and wherever, whichever path where you did that init. So this .dbt was created by then. So, and this profile was also created by them. So let me open this profile. It's already opened here. So this profile by default, it will be default. This will be named as default, and it will have dev, prod, and different credentials inside. So since we are going to use only dev here, I'm just mentioned dev. So you can also have another profile setup for prod and different connection parameters. So in order to configure this, you have this DBT documentation where you can go to reference DBT serials where you can configure profiles for different providers like Snowflake, Redshift, Postgres, BigQuery, etc. So looking at Snowflake, what is what I have configured here. So the type Snowflake and account ID is something you'll have to go to your Snowflake here. Up to this will be your account ID. That is after HTTPS, whatever you choose from here till here will be your account ID. And I've just mentioned that the username and password which I used to enter into Snowflake, you will be creating a trial account and you can use that here. And the role, I have kept the highest admin as account admin here. So, and the database is something what we created, USDA nutrient. So warehouse, I think let me just change it to, or let it be default. This is also warehouse is available, and schema is public, and threads is something you can define from 1 to 10, whatever you want. So now once the profile is set up, so now I'll just run a command called dbt debug here. Okay, this is in the terminal. You can click on the terminal here when you are on the page, and you just say dbt debug in order to check whether your connection is successful or not. So it says my connection is found. So I am able to connect to Snowflake using this credential to this database and account credentials now. So when I now run my dbt, another command, like I'll just say, when I say dbt run now, what it will do is it will deploy all the models here inside the Snowflake connections which I have given. So let me just say dbt run. So it says it found 2 models, 4 tests, 0 snapshots. So since this is a basic thing, so it's running now. Okay, so this has been now deployed. Now when I go to my Snowflake, go to my database, use the meeting. It should have come here, but not sure why it has not come. Actually, check. There is some problem. Okay, it's because I have mentioned it as account admin. I think it's not showing up in the current login scheme where I have actually been. Let me change to account admin and see if I'm able to see that. Still, it's not showing up. Not sure why it's not showing up. Let me just check again. Doesn't give me any error too. Yeah, it's done here. My first DBT model is something what we tried here. So this is how DBT can be useful, and so we can write SQL queries within DBT, and we can deploy it here on. And so in this demo and session, actually, we didn't go through what do you say, uh, all the features within DBT actually. As I said, the game-changing thing what we see here is the deploy, documentation, automation testing, and transformation, version control, stuff like that. But with the interest of time, what we did is just installed DBT and just try to push a simple code into Snowflake, and that is what we did. But we can do multiple stuff here. But within this session scope, I think we have just taken the basic stuff here. So I think that's it about the demo. So I guess I'm done with the demo now. So if you have any questions, I think we are 20 minutes over now. I'm sorry it took some time, but if you have any questions, I'm happy to answer.
Very well done, Ronaldo. I really liked it. Thanks for taking the time to give us the demo also.
Yeah, thank you very much.
Oh, perfect. Thank you so much.
Yeah, thank you. Thank you everyone. So, thank you. Thank you very much.
Bye.
Have a good day all. Bye.
Yeah, you too. Bye.